Hello everyone. We are now going to begin our lecture on the second part of trigonometric functions based on the unit circle. Now in our previous lectures we looked at trigonometric functions using right angle triangles, and the angle measures there were given to us in degrees. Angles, as you know, can also be measured in radians, which are real numbers, and to represent the trigonometric functions of angles measured in radians, we will be using the unit circle drawn on an XY rectangular coordinate plane. Now we are going to cover quite a lot in this lecture, but we are going to begin by using a unit circle to define trigonometric functions of real numbers. That means the angles measures that we will work with will be in terms of radian measures. And then we will talk about how we can recognize the domain and range of the sine and cosine functions. Domain meaning the values that can be input into a sine and cosine function, and then the range represents the values we can expect as outputs from the sine and cosine functions. We will also learn how to find exact values of the trigonometric functions at pi over 4, which is the equivalent of a 45-degree angle. We will talk about using even and odd trigonometric functions, recognize and use fundamental identities. In our previous lecture, we already learned about the co-function identities. Here we will be introduced to some more fundamental trigonometric identities. We learn using periodic properties and then finally evaluating trigonometric functions with a calculator. Let's begin by going over what a unit circle is. A unit circle is a circle with a radius measuring 1 unit, and the circle is drawn around the point of intersection between the x and y axis in a rectangular coordinate plane. So the center point of the circle will lie at the point of intersection at the origin rectangular coordinate plane. The radius of the circle will be 1 unit, and recall what the equation of the unit circle is. The equation is x squared plus y squared equals r squared. So let me write that down. The equation for any circle, not just the unit circle, but for any circle is x squared plus y squared equals r squared. Now when r is of a unit measure of 1, then it becomes x squared plus y squared equals 1 squared. Therefore, the unit circle will have an equation which is x squared plus y squared equals 1. Now, in a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. Both are given by the same real number t. Over here, a central angle is the angle formed at the point of intersection in the rectangular coordinate plane or at the origin, correct? So over here, this is the central angle, and the central angle is measured in radians. If you recall from a previous lecture, the measure of a central angle is equal to S divided by R, correct? What is S? S is the section of the arc in this unit circle that is intercepted by this central angle. That is what S is. It's the length of the arc of the unit circle that has been intercepted by the central angle. And theta is measured as S over R in radians, and in a unit circle R is always 1. So it would be S divided by 1. Therefore, theta, or that angle, will have a measure of S radians. All right? We are now going to learn how to represent the 6 trigonometric functions in terms of a unit circle. Previously, we learned how to define the 6 trigonometric functions using the sides of a right angle triangle. I'm going to quickly review that here. I'm going to draw a right triangle, and the right angle of a right triangle is normally indicated with the capital letter C, and the side opposite to it, which is also called the hypotenuse, is indicated by a corresponding lowercase c, and then the other two angles A and B have the sides opposite to them indicated by their corresponding lowercase letters. So the side opposite angle A will be shown as lowercase a, the side opposite angle B will be denoted with the lowercase b. Now, we can take any one of these acute angles, we can name them alpha, beta, and so on. But when we find the sine ratio or the cosine ratio of any one of these angles, alpha or beta, just to make things a little more clearer, I'm going to mark the angle B as beta and angle A as alpha. So if we want to find the trigonometric ratio of any one of these angles, we define the sine function as opposite side to that angle divided by the hypotenuse, correct? Likewise, cosine was defined to be the adjacent side over the hypotenuse. So the side that's adjacent to the angle we are working with. If we want to find the cosine of angle beta, then the adjacent side to beta is A, correct? So it would be A over C. If we are dealing with angle alpha, which is right here on top, the adjacent side to that is the side B. So B over C, adjacent over the hypotenuse. And then we have the tangent, which was defined as opposite over adjacent. So that would be, if we are working with angle alpha, then the opposite side is A over adjacent side is a B, A over B. So that is how we learn to define the six trigonometric functions using the sides of a right triangle. Now, what do we do in the case of a unit circle? Where do we get the sides and their respective measures from? A unit circle, recall, has a radius of 1 unit, and the angle is called the central angle, which is formed at the point of intersection between the x and the y axis. Now, what we do is we take a point on the terminal side. So in this picture over here, you see the initial side always lies along the positive x-axis, and the terminal side is the side that moves about the point of origin to form an angle with the x-axis, correct? So we take this terminal side and we take a point on the unit circle. So the point of interest is the point where the terminal side touches the unit circle. So this point here, and we are going to name that point P, and it's going to have an x and a y coordinate. So this point here is what I'm referring to. This point will have coordinates x and y. What is x? X is the distance along the x-axis, and y is the distance up from here, right? This is our y. So this distance is x and this distance is y. So now you see we have a picture of a right angle triangle. So here the right angle is over here on the x-axis. We go along the x-axis horizontally and then we go vertically up, and that forms the measure y. And then this here is the radius, or it is the hypotenuse of the right triangle. So we have formed a right angle triangle on the unit circle. And now we are going to use these sides to come up with our trigonometric functions. So sine is opposite over hypotenuse, correct? That's what sine is. So let's write that. Sine is opposite over hypotenuse. Therefore, if this angle, and it's always this angle on a unit circle, it's the angle formed at the intersection point between the x and the y axis. So the side which is opposite to this angle is y, correct? Here we go. This is the angle. The side opposite to that angle is y. So opposite is going to be y divided by, what is the measure of the hypotenuse? It is r. The hypotenuse is the radius of this circle. It's a line that goes from the center of the circle all the way to the circumference of the circle. That's what the radius of the circle is, and a unit circle will always have a radius measuring 1 unit. So in this case, what is r? R is 1, so y divided by 1, and therefore they say sine of t is y. We can ignore the r, although there is an r, but because its value is a 1, we can drop it and just write it as y. How about cos of t? Cos of t has the ratio of adjacent over hypotenuse. So let's find out what the adjacent side to this angle here is. The adjacent side is x, correct? So it's x divided by r. Let's write that. It's x divided by r. However, because r has a value of 1, therefore it's x divided by 1. Therefore, it's simply x for cos of t. How about tan of t? Tan of t is opposite over adjacent. So what is the side opposite to the central angle? Is y. The side adjacent to the central angle is x. So that's y over x. So we just have to take whatever value y is, divide it by the value of x, right? Y divided by x. However, x cannot be a 0 because that would make the tan ratio undefined, correct? As far as cosecant, secant, and cotangent ratios are concerned, we just take the reciprocals of the sine, cosine, and tan ratios respectively. So what was y divided by 1 now becomes 1 divided by y. Secant is 1 divided by x, and tangent, or rather cotangent, is x divided by y. All right, so now we have learned how to define the 6 trigonometric functions in terms of a unit circle. Let's work on an example now to find the different trigonometric functions of a central angle along a unit circle. How do I know this is a unit circle? This equation here tells me it's a unit circle. How? It says x squared plus y squared equals 1. So r squared here has a value of 1. So when r squared equals 1, that means the radius r is equal to square root over 1, which is a 1. And when the radius of a circle is 1, it's a unit circle. So this distance here from the point of origin to the point on the circumference of the unit circle has a measure of 1, and that's the radius of this circle. They've also given us a point on the terminal side. This is the point where the terminal side touches the circumference of the unit circle. The coordinates of that point has the following values. It's given here, but it's too small to read perhaps, so I'm going to write it out. The x coordinate is square root over 3 divided by 2, and the y coordinate has a value of 1/2. So this is x, and half is the value of y. What does that mean with reference to this particular angle? I'm going to drop a line from the point to the x-axis vertically down. And when I do that, I get the figure of a right triangle here. And what is x? X is the distance from the origin to the point where the line touches the x-axis. So this distance square root over 3 divided by 2. So I'm going to write that. It represents x, which is square root over 3 divided by 2. And this line here, the vertical distance from the x-axis up to the point, is what y is. Y equals 1/2. This distance from the point to the x-axis is 1/2, and that's what the y coordinate is equal to, correct? And y is the opposite side to the central angle. So the central angle T has the opposite side as y and the adjacent side as square root over 3 divided by 2. So now let's try to find the different trigonometric functions. We know that the sine function is defined as the opposite side to the angle divided by the hypotenuse, the measure of the hypotenuse. So y is the opposite side and x represents the adjacent side to the angle. So given that, the opposite will be denoted by y. Hypotenuse is r, right? This is the hypotenuse. So since r has a measure of 1 and y has a measure of half, so half divided by 1 is 1/2. Therefore, sine of t is equal to 1/2. The next one is cosine of t. Cos is defined by the function adjacent over hypotenuse. Now, adjacent side is x. So let's write it as x divided by r, and x has a value of square root over 3 divided by 2. So square root over 3 divided by 2, and r is 1. Therefore, cosine of t is square root over 3 divided by 2. And then we have tan of t, and that is defined as being opposite over adjacent. So opposite side would be y divided by x. Y has a value of 1/2. X has a value of square root over 3 divided by 2, which is 1 divided by square root over 3. And whenever there is radical in the denominator, always make it a point to get rid of it by rationalizing. How do we do that? We multiply both the numerators and the denominators by square root over 3 to get a value of square root over 3 divided by 3. And that should be the final answer for tan of t. So let me pull up the solutions and see if that matches with what we got. So sine of t is y equals 1/2, and that's exactly what we found as well. Cos of t is x equals square root over 3 by 2 is what they got, and that's exactly what we got as well. And then tan of t is y divided by x, so that's half divided by square root over 3 divided by 2, and then they go on to rationalize this and they get an answer of square root over 3 divided by 3. Now let's see what the reciprocal functions of sine, cosine and tangent would be for the same central angle T, the same unit circle and the same coordinates for point P. So let me write those coordinate values because we are going to use them again. So square root over 3 divided by 2 was the value of x and 1/2 was the value of y. Cosecant of t is 1 divided by y. Recall that sine was equal to y, so the reciprocal of that would be 1 over y. Y has a value of 1/2, so 1 divided by 1/2 should give us a 2, and that's what they got here. Secant is the reciprocal of cosine. Cosine was equal to x, therefore secant would be 1 divided by x. So we have 1 divided by square root over 3 divided by 2. And when we do this division, we end up with 2 over square root over 3, and we end up with a radical in the denominator. To get rid of that, we multiply both the numerator and the denominator by square root over 3. We end up with an answer 2 times square root over 3 divided by 3. As far as cotangent is concerned, that's the reciprocal of tangent. If tangent was y over x, then cotangent would be x over y is the reciprocal. So again, plug in the value for x, that's square root over 3 divided by 2, and y is 1/2. When you complete this division, you should come up with a value of square root over 3, and that's what we are now going to learn about the domain and the range of the sine and the cosine functions. But before that, let's clarify what we understand by the domain and range of function. The domain of a function represents all the values that we can input into the function and come up with a real number as an output. The range of a function, on the other hand, represents all the output values that can come up after we do the calculation of the function after plugging in the different domain values. Right? So in the case of the sine and the cosine function, the values that can be input into these functions that will give us a real number as an output would be the entire set of real numbers. So in set theory, we write it as negative infinity to positive infinity. That represents the domain of these two sine and cosine functions. As far as the range of the functions are concerned, the output values, in other words, would be from -1 to +1, the set of all real numbers between these two values inclusive. Inclusive means that we can have an output value of -1 as well as +1 and everything else in between those two values. All right? So I'm going to write down the sine and the cosine functions. We have f of t. So the function f of t is equal to sine of t, where t can be any angle in radian. And we can also have f of t equals cosine of t. And if you recall, sine of t in a unit circle is equal to y, whatever the y coordinate at a particular angle is. Cosine of t is x, correct, in a unit circle. What I'm going to do next is I'm going to pull up a figure of a unit circle and try to explain why the range values are restricted between -1 and +1 inclusive. And for that, I'm going to look at the angles just at the axis. So we have a 0-degree angle. So when the terminal side and the initial side overlap along the positive x-axis, it forms a 0 degrees or a 0 radian angle. What are the coordinates of the point on the unit circle formed by that angle? I'm going to name that point P, but the coordinates of it would be 1, 0. That means the x coordinate is a 1 and the y coordinate is a 0, correct? This distance along the horizontal line has a measure of 1 and there's no vertical rise at all. It stays along the x-axis. So y is 0 at this point. How do I know that x is 1? Because this is the radius of the circle. This is a unit circle, and the unit circle always has radius 1, correct? The next angle on the axis is this pi over 2 radians, or the 90-degree angle. What are the coordinates at this point? Again, x at this point is 0, so x is 0. There's no horizontal displacement. Y, however, is +1. So this is x, this is y, 0, 1. Next is pi radians, or the 180-degree angle. The coordinates at this point would be -1 for x and 0 for y. And then we have the 270-degree angle equivalent, which is 3 pi over, which is the same as 270-degree angle. And that has coordinates of 0, -1. At this point, x is 0, but this is the negative y-axis, so y is -1, again in a unit circle. So now let's observe the y values first, all right, because sine of t is equal to y. Y starts off with a 0 and then it goes as high as 1. So as we start forming the angle between 0 and the 90-degree angle or pi over 2 radian angle, it reaches a maximum of 1. So y at this point is 1. And then after we move away from pi over 2, what happens to the y value? It starts decreasing and then it becomes 0 at pi radians, pi or 180 degrees. Y is 0. This is y, this is x. And then it starts decreasing further and we get a y value of -1, so x comma y. And then it starts increasing from -1 and comes back to 0 again. So you see the lowest value that y takes is a -1. The highest value that y takes is a +1 at pi over 2 radians. It does not extend beyond these two values of -1 and +1. So it includes all values between that range, but it does not extend beyond -1 and +1. That matches with what we gave as the range of the sine function. If you look at the cosine function, you'll notice the same thing, only that x starts with a value of 1, the angle is 0 radians, and then it decreases to a 0, then it gets as low as -1, then it starts increasing again, becomes a 0, and then once we go around, it becomes +1. So the lowest that cosine can be is a -1. The highest that it can be is a +1. And that is the reason we say that the range of these functions will be between -1 and +1 inclusive. It does not extend beyond that range, right? Now, in the next couple of slides, we are going to go through the process of finding the exact values of the trigonometric functions when the angle is pi over 4. Now, pi over 4 is the same as a 45-degree angle. So let's see what this slide has to say, and then we are going to go on to the next one where we will discuss the process and explain why the function values are what they are. It says here the trigonometric functions at t equals pi over 4 occur frequently. We use the unit circle to find the values of the trigonometric functions, that means the sine, cosine, tan, and their reciprocals at t equals pi over 4. So they have a picture of the unit circle here, and this line here forms the pi over 4 radian angle. And we can extend the line along the negative x-axis, and we will see that this line has an equation of y equals x. So it says here, we see that point P, which is the point right here, lies on the line y equals x. Thus, point P has equal x and y coordinates, right? If y is the same as x as defined by the equation of the line, that means x and y are the same values. So we find these coordinates as follows. X squared plus y squared equals 1. That is the equation of a unit circle. We already know that, where 1 is the value of r squared. So r is equal to 1. And therefore, as far as right triangle is concerned, a squared plus b squared is equal to 1. So point P equals a comma b. It lies on the unit circle. Now I'm going to move on to the next slide and explain how to find the trigonometric functions, the values of the functions, given that the coordinates of the point P for a pi over 4 radian angle are going to be the same. But what exactly is it going to be, right? We are now going to go through the exercise of finding the exact values of the trigonometric functions of a special angle, which is pi over 4 radians, which is the same as a 45-degree angle. We are going to start by finding the length of the sides of a right triangle which has a 45-degree angle in it. And once we have the measures of the sides, we will use those on the unit circle, and then we will be able to find the different trigonometric functions. So I'm going to begin by first drawing here a right triangle, because we need to talk about the properties of a right triangle whose one of the acute angles measure 45 degrees. So here I have the picture of a right triangle. I'm going to label the right angle of the triangle with C, and the side opposite to it, which is also the hypotenuse of the right triangle, is going to be labeled with the lowercase c, and then we will have the two acute angles labeled as A and B, whereas the sides opposite to those angles are going to be labeled with the lowercase letters of the corresponding angle. So we will have side A opposite to angle A and side B opposite to angle B. Now I'm going to mark one of the angles over here. Let's say angle B has a measure of 45 degrees, which is the same as pi over 4. Now in a right triangle, if any one of the acute angle measures 45 degrees, then the other angle automatically measures 45 degrees from a geometric theorem which states that the sum of the angles of any triangle must always be equal to 180 degrees. And when we have two angles in a triangle of the same measure, then the sides opposite to those angles will also be of equal length. That's given by another theorem in geometry. Since we have two angles here of 45 degrees, they measure the same, therefore the sides A and B will also be of the same length. A will be whatever B is and B will be whatever A is, so we can remove this B and label that as A. Now we have to take this over to a unit circle. Now the equation of any circle is x squared plus y squared equals r squared, where r represents the radius of the circle, which corresponds to the hypotenuse of a right triangle. In a unit circle, the radius is always equal to 1 unit. So we write this equation here. We replace the r with a 1. So we have x squared plus y squared equals 1 squared, which is equal to 1. Correct? 1 squared is 1. And they have used this same equation here. They've replaced x and y by A and B. We are going to use that to come up with the values of the length of each of these sides. So here we are going to show the step-by-step work of finding the value of A, and once we find the value of A, we will have the value of B because they are of the same length. Here on the left hand side, they've written this as A squared plus A squared equals 1. Both are A squared because the two sides are the same. So just for a 45-degree angle, because A is equal to B, we can replace the B with the A and write it as A squared plus A squared equals 1. In the next step, we are going to combine the two terms, A squared plus A squared. We can add them, they are like terms, and write that as 2A squared equals 1. Next, we will have to solve for A. First, we will be dividing both sides by 2 to isolate a squared. Let's do that. So we have a squared equals 1/2. The next step would be to take the square root of both sides. So we will get a equals 1/2. Square root of a squared is a. Square root of 1/2 is square root of 1/2. But we can distribute the square root to both the numerator and the denominator and write this as square root over 1 divided by square root over 2. And square root over 1 is 1. So we end up with 1 divided by square root over 2. However, we do not like to keep a radical in the denominator, so we have to rationalize that, and that's what they do in the next step, where it says a equals b equals square root over 1/2, which is 1 divided by square root over 2. In order to rationalize that, they have multiplied both the numerator and the denominator by square root over 2 for a value of square root over 2 divided by 2. So the values of each of these two sides of the right triangle, where the hypotenuse measures 1 and one of the acute angles is 45 degrees, is going to be square root over 2 divided by 2, whether it is side A or the other leg, which is side B. Right? I'm going to bring up a unit circle to show how that translates to a unit circle concept. Here we see pi over 4 radian central angle, correct? And this point here, where the terminal side intercepts the circumference of the unit circle, has a point P, and I'm going to mark that point. And that point is important because if you drop a line down to the x-axis and the distance along the horizontal line, they represent the two legs of a right triangle that has one of the acute angles measuring pi over 4, a 45-degree angle. So here we have x, here we have y, and if the central angle measures pi over 4, then x and y will have the same measure of square root over 2 divided by 2, and same for x, square root over 2 divided by 2. So this point here, P, will have the coordinate square root over 2 divided by 2, comma, square root over 2 divided by 2. And then we are going to go ahead and use those x and y values. For example, sine of pi over 4 is going to be the y value, which is square root over 2 by 2. Cos of x is going to be the x coordinate of this point, which is square root over 2 by 2, and so on. In the next slide, we are going to use these two coordinates to find the values of the trigonometric functions at t equals pi over 4. All right? Now we are going to find the 6 trigonometric function values for pi over 4, but in this slide they've just given cosecant, secant, and cotangent, but I'm going to write out the function values for sine, cosine, and tangent functions as well. So let's just list the values of the three sides we just found. For a pi over 4 radian angle, we will have the x value being square root over 2 divided by 2, as we saw over here in this unit circle picture. Y is going to be the y coordinate of this point P. So y equals square root over 2 divided by 2. And what is r going to be? R, which is the measure of the hypotenuse of this right triangle. So from point P, I'm going to drop this line vertically to the x-axis, and that length measures square root over 2 divided by 2, and then this x, the distance along the x-axis, which will represent the x coordinate, is going to also be of the same measure, which is square root over 2 divided by 2, and r, which is hypotenuse of this right triangle figure, is 1. Correct? So given we have these three side measures, we can find sine pi over 4, y equals
square root over 2 by 2. Cosine of pi over 4 is equal to x, which is square root over 2 divided by 2. And tangent of pi over 4 is y divided by x, which is square root over 2 divided by 2 over square root over 2 divided by 2, which has a value of 1. So these are the sine, cosine, and the tangent function values of pi over 4. Next, we are going to find the values of their reciprocals. So cosecant of pi over 4. Let's find that. So they are using the coordinates for p, which is square root over 2 by 2, comma, square root over 2 by 2, to find the cosecant, secant, and cotangent functions. Cosecant will be pi over 4, which is equal to 1 over pi, which is 1 divided by square root over 2 divided by 2, which a value of square root over 2. Next is secant of pi over 4 is 1 divided by x, and you should get the same value as cosecant. If sine and cosine functions have the same values, then cosecant and secant, their reciprocals will also have the same value. As regards cotangent, we have pi over 4 equals x divided by y, which is square root over 2 divided by 2 divided by square root over 2 divided by 2 should come up with a value of 1 for the answer. All right. So here's a complete listing of all the 6 trigonometric functions of pi over 4. We see that sine and cosine of pi over 4 have the same values. Cosecant and secant functions have the same values. And tangent and cotangent functions have the same values of 1. We are now going to learn which of the 6 trigonometric functions are even functions and which of them are odd functions. Now, the concept of even and odd functions was covered previously in pre-calc 1, but I'm going to review it one more time. In an even function, if you replace the x value with its negative counterpart, then you will get the same answer as what the result was when you calculated the function using the positive value of x. So whether you input a negative value or a positive value into the function, the result will be the same, in other words. So this is considered to be an even function. So given that of the 6 trigonometric functions, only the cosine function and its reciprocal, the secant function, are even function. The rest of the functions are odd functions, but let's try to work this out, the cosine and the secant functions, for the angle of pi over 4, knowing that it is an even function. Let's take the pi over 4 angle. Cos of pi over 4, if we replace pi over 4 by its negative counterpart, which is negative pi over 4, then we will get the same answer as cos of pi over 4, which is square root over 2 divided by 2. All right. So whether you plug in a negative angle or a positive angle into the cosine function, you're going to get the same result for the answer. Secant also follows the same principle. It's an even function. So secant of negative pi over 4 is going to be whatever secant of positive pi over 4 was. And we just learned that secant is square root over 2 for a pi over 4 radian angle. So whether you substitute a negative angle or a positive angle into the function, you will get the same result. An odd function is one where when you substitute a negative value into a function, the result is negative f of x. That means whatever the result was when you plugged in a positive x value, the answer will be the negative version of it, in other words. So look here, all these four functions, sine, its reciprocal cosecant, tan, its reciprocal cotangent, they are all odd functions. What does that mean? Sine of negative t is equal to negative sine of t. So whatever you found using the positive angle, if you substituted the negative of it, you would get the negative of the answer. In other words, let's work with an example here. Sine of negative pi over 4 will be equal to negative sine of positive pi over 4. Now, recall what sine of pi over 4 was. It was square root over 2 divided by 2. But because this is an odd function, it will be negative square root over 2 by 2. All right. So whatever it was with the positive angle, the negative angle will produce a value which is the negative of the positive angle value. For cosecant of negative pi over 4 would be negative of whatever cosecant of pi over 4 was, which is negative square root over 2. For tangent and cotangent, it's the same rule for the odd function. So tan of negative pi over 4 would be equal to negative tan of pi over 4, which is negative 1. For cotangent, it's the same story. Cotangent of negative pi over 4 is equal to negative cotangent of positive pi over 4, which is negative 1. So that's how the even and odd functions work for the trigonometric functions. Just remember, cosine and the secant are the only two functions that are even. The rest of the trigonometric functions are all odd functions. We have here a couple of examples that we already worked out in the previous slide, but let's go through them one more time. Over here, the first one says we have to find the value of each trigonometric functions using our knowledge of the even and odd functions. Secant, we know, is an even function, so they're asking us to find the secant value of negative pi over 4, which is going to be the same as secant of the positive angle, which is square root over 2. For sine of negative pi over 4, this is an odd function. So sine of negative pi over 4 is going to be the negative of whatever sine of positive pi over 4 was. Sine of pi over 4 was square root over 2 by 2, but we have to remember to put a negative sign before it because it's an odd function. So it's going to be the negative of whatever sine of pi over 4 was. All right.